Okay, good afternoon, all of you. Am I audible?
Yes.
Okay. So, we will solve next example on overhanging beam. Okay. So, please draw figure. I will draw here simultaneously. You can also draw. Okay. Those students are present in classroom. Please don't discuss. Okay, I will draw figure here. You can also draw. Okay, so at A end, simple support is provided. Here A, at B point, one moment couple is applied. Okay, so here B point is there. And the intensity of moment couple is 25 kilonewton meter. 25 kilonewton meter. After that, in between B to C, there is no any force. And from C to end of this beam, uniformly distributed load is applied. So here C, and this is D point. At D point, point load is applied. So here intensity of point load is 50 kilonewton. Okay, and the intensity of this uniformly distributed load is 10 kilonewton per meter. 10 kilonewton per meter. This is E point. This is E point. And this is F point. Okay, so span is 1, 1. Here 2.5 meter. Here 0.5 meter. And last one is 2 meter. So as usual, our D to E 0.5. Span between D to E is 0.5. Okay. So as per our procedure, we have to calculate RA and RE. So step number 1 is reaction calculation. Step number 1 is reaction calculation. So in that there are two conditions. First is summation FV, which is equal to 0. So vertical forces, upward forces positive, downward forces negative. So this RA and RE going upward. So RA plus RE. After that, this 10 kilonewton force going downward. So minus 10 into, you tell me perpendicular distance for this. 3 or 5? 2.5 plus 0.5 is 3 meter. And after that 2 meter. That means 5 meter. Okay. So 10 into 5. And then this 50 kilonewton going downward. So minus 50, which is equal to 0. Now you calculate this. I think RA plus RE, which is equal to 100. Right? Yes, RA plus RE, which is equal to 100 kilonewton. This is our equation first. Then we will apply second condition. Summation moment at A, which is equal to 0. We will take moment at A. And we will start from this E point. So RE creates anti-clockwise movement. So minus RE into perpendicular distance is 5 meter. Okay. After that, this 50 creates clockwise. So plus 50 into perpendicular distance is 4.5. After that, this 10 kilonewton per meter creates clockwise. So plus, okay, plus 10 into span for this is 2.5 plus 0.5 plus 2 meter. That is 5 meter. And it will act at 5 by 2 plus. Now from this, we have to add this 2 meter distance. Okay, because of span is from C to F 5 meter. And we have to add this 2 meter distance. So plus 2. Okay. Minus 25 because of this movement couple is anti-clockwise. So minus 25 which is equal to 0. Now I will shift this RE into 5 to right side. You do these calculations. Which is equal to how much? Yes, I want answer from Aditya. Pravar. Sang Aditya. Yes. Okay, 4 to 5. So RE which is equal to 4 to 5 divided by 5. Then RE which is equal to 85 kilonewton. Now we will substitute this value in equation 1 and we will calculate the value of RA. Okay, so I will write here. Put RE in equation 1. In equation 1. So our equation 1 is RA plus RE which is equal to 100. So RA which is equal to 100 minus 85. So simple, RA which is equal to 15 kilonewton. 15 kilonewton. Now we got the values of RA and RE. We will move towards shear force calculation. So RA is 15 and RE is 85. So second step is shear force calculations. Shear force calculations. Okay. So we will calculate shear force at A. Yes. Now you tell me shear force at A which is equal to plus or minus? Plus 15 because of this force is going upward. After that you observe here in between A to B there is no force. And at B there is no any vertical force because of this is movement couple and we are dealing with vertical forces. So shear force at B again, shear force at B which is equal to plus 15 kilonewton. After that you see in between B to C there is no force and at C there is no any vertical force. So shear force at C which is equal to same. Shear force at C which is equal to plus 15 kilonewton. Okay, as it is. Now we will calculate shear force at D. Okay, shear force at D but before point load. Now you can concentrate here. Here two loads are there. In between C to D, one UDL is there. And at D, one point load. So first we will calculate without considering point load. And after that we will calculate considering point load. So shear force at D but before point load. Before point load. That means without considering point load, which is equal to. Now up to C point, force is plus 15. Okay. I will write below, so you will get easily. Up to C point, force is plus 15. After that, in between C to D, downward uniformly distributed load is applied. So minus 10 into perpendicular distance. That is span for C to D is how much? 2.5. So 2.5, which is equal to. So now you calculate and tell me. Minus 10 kilonewton. After that, we will calculate at D with considering this 50. So shear force at D, but after point load, after point load, after point load, which is equal to, okay, up to this D point, shear force is minus 10. And at D point, downward 50 load is there. So minus 50, which is equal to how much? 24? Yes, minus 60. Minus 60 kilonewton. After that, we will calculate at E. But here again, we have to calculate 2 times. Because of in between D to E, uniformly distributed load is there. So first we will calculate before RE, and after that we will calculate after RE. So shear force at E, but before RE. Before RE, that means without considering reaction. So up to D point, shear force is minus 60. Minus 60. Now you observe here in between D to E, uniformly distributed load is there and it acting downward. So minus intensity is 10 into span for this D to E is 0.5. So you calculate and tell me. Minus 65, no? Minus 65 kilonewton. Okay. Now we will calculate at E point. Okay. After RE. So shear force at E. Shear force at E after RE. After RE. That means with considering reaction. So up to this E point, shear force is minus 65 and at E point upward force is there. So plus 85, which is equal to 20 kilonewton. Okay, plus 20 kilonewton. Now we will calculate at F. Okay, so shear force at F, which is equal to, up to this E point, force is 20 and in between E to F, uniformly distributed load is applied and this is going downward. So minus 10 into perpendicular distance is 2. So which is equal to 0 kilonewton. Okay, so these are the shear force calculations. Now we will move towards bending moment calculations. But before that, we will calculate zero shear force location. Where zero shear force will come? How to identify from these values? कसं identify करणार आहोत? तेच सांगा की कुठल्या पॉइंटला चेंज होतं?
ई पॉइंटला मॅडम.
Shear force at D before point load. Okay, you observe here at this point shear force value is minus 10 and at C is plus 15. So plus to minus, that means in between C to D, the value of shear force is 0. So we have to calculate location. So we will find SF is 0. SF is 0 at X meter distance, X from C. From C. We will assume from this C. We will assume here X meter distance. Okay. So our equation is plus 15. Okay, plus 15 minus 10 into X, which is equal to 0. So 15, which is equal to 10x. So X, which is equal to 15 divided by 10. So X, which is equal to 1.5 meter, but from which point?
C.
From C. And suppose I want this distance from D, then how I will calculate? X, which is equal to how much from D? कसं काढायला लागेल? बघा हे टोटल स्पॅन 2.5 मीटर आहे. सी कडून 1.5 ला आहे, तर डी कडून किती येणार मग? X, which is equal to 2.5 minus 1.5, which is equal to 1 meter. But you mention here from D. I'm calculating from D because of we are calculating movement from this F side. So at that time, this distance is required. So at that time, your confusion, to avoid confusion, we will calculate here. Okay.
प्लस मायनस 10 घेतले की कसं म्हणतात प्लस तुम्ही
कुठलं
15 घेताना तुम्ही मायनस 10 ऍड करा इक्वल टू 0 ते 15 जागा मी मायनस घेतले की सारखे म्हणून 3 ऍड करा साइन चेंज
तसं साइन कसं चेंज करणार ना Okay. Now we will move towards bending moment calculations. Okay, next step is bending moment calculations. Step number 3, bending moment calculations. Bending moment calculation. So bending moment at F, which is equal to yes, fast 0 kilonewton meter. After that, we will calculate bending moment at E. Bending moment at E, which is equal to span for this. Suppose this is our E point. Here UDL is applied. This is 2 meter. This is F, and intensity is 10 kilonewton per meter. So this pushes downward. So minus 10 into 2 into 2 by 2, which is equal to how much? Minus 20 kilonewton meter. After that, we will calculate bending moment at D point. Okay, bending moment at D. So bending moment at D, which is equal to, for this I will draw span here. Here RE 85. This span is 2 meter. Here uniformly distributed load is applied, and here D point is there. Okay. So whole uniformly distributed load. This is 10 kilonewton per meter, and this is 0.5 meter. Yes, tell me how to calculate moment. Okay, first we will start from this. Okay, so this 85 going upward, so 85 into 2, sorry, 0.5. 85 into 0.5. After that, minus 10 into 2.5 into 2.5 divided by 2. So calculate and tell me bending moment at D, which is equal to how much? Plus or minus? 11.25 kilonewton meter. Okay. So this is the movement up to D point. Now we will calculate bending moment at C. But before that, we will calculate maximum bending moment. Because of zero shear force location is in between C to D. Where shear force is 0, at that point bending moment is maximum. So shear force is 0 at 1.5 meter from C. So at this point we will calculate maximum bending moment. So next step is maximum bending moment. Maximum bending moment, which is equal to, okay, for this I will draw span here. So here E point 85. Okay. After that, here F. D. A. 1 minute. 475. बघा RE into 2.5 plus 0.5 3 झाले 1 and 1 5 झालं इथपर्यंत क्लिअर आहे. Then we will move toward this 50. 50 creates clockwise. So 50 into perpendicular distance is how much? 2.5 plus 2 4.5. ह्याच्यात काही डाऊट आहे का? नाही. पुढे आता आपण या UDL कडे येऊया. ठीक आहे. हा युनिफॉर्मली डिस्ट्रीब्युटेड लोडची इंटेन्सिटी किती आहे तुमची 10. स्पॅन किती आहे त्याचा टोटल 5 मीटर आहे. बरोबर आहे. 10 into 5 and it creates clockwise movement. That's why we have written here plus. तो त्या पर्टिक्युलर स्पॅनच्या हाफ लॅक होणार आहे म्हणजे 5/2. But from C to A distance is 2. So plus 2. And this 25 is already movement and this is anti-clockwise. So minus 25 which is equal to 425 is correct answer. चेक करा एकदा मी थांबते 1-2 मिनिट. Okay, next we will calculate maximum bending moment. So please, here X section from this D to X distance is 1 meter. Okay, so here span is here 85 force. This is 2 meter. Okay, from E to D, 1 force is there, 1 point load. Okay, this span is 0.5. This is D point. This is E point. This is E point, and the load at D is 50 kilonewton, and we have taken here XX section, and this distance is 1 meter. So from D 1 meter and from C 1.5 meter. Now we will calculate moment for this. Okay. Yes, this UDL is continue up to this point. Yeah, up to this point. Okay, so first we will consider this 85. So this pushes upward, so plus 85 into 1.5. Okay, after that we will move toward this point load. This pushes downward, so minus 50 into perpendicular distance is 1 meter. Okay, now we will calculate for this UDL, and the intensity of UDL is 10 kilonewton per meter. Okay, and this pushes downward, so minus 10 into perpendicular distance is 3.5. 2 plus 1 3 and 0.5 is 3.5, and then it will act by 3.5/2. Now you calculate and tell me. 16.25. So plus or minus what? प्लसच येणार. 85 सगळ्यात मोठा फोर्स आहे ना, बाकीचे फोर्स कमी आहेत. सो प्लस 16.25 kilonewton meter. So this is the maximum value. At the same time, you have to pay attention here. The values of bending moment for remaining points should be less than this 16.25. If remaining points value is greater than this 16.25, then definitely we have done some mistake. Okay, up to this point, you check here, bending moment is below 16.25. Yes, at F0, at E, minus 20. Here some mistake is there. Here 16.25. Okay, here bending moment at D is 11.25. ओके, इथं मिस्टेक पण म्हणता येणार नाही, पण इथला आन्सर तर बरोबर आहे. मग इथली व्हॅल्यू काय चुकते का चेक करा बरोबर. मॅक्सिमम बेंडिंग व्हॅल्यूचा आन्सर हे कॅल्क्युलेशन फक्त एकदा करून बघा. बरोबर आहे ना? ठीक आहे. आता इथे हे सिम्पली सपोर्टेड आणि कॅन्टिलिव्हरचं कॉम्बिनेशन असल्यामुळे थोडं व्हॅल्यू प्लस मायनस होत असेल. आपण पुढचे पॉईंट चेक करूया. नेक्स्ट वी हॅव टू कॅल्क्युलेट बेंडिंग मोमेंट ऍट which point is remaining? C point. Okay, so for this C point we will calculate moment from this left side, from this left side. So bending moment at C, bending moment at C, which is equal to, but we will consider from this left side. Here 15 na? Yes, 15. Here 2 meter span is there, right? 1 C पर्यंत 1 आहे. ठीक आहे. Here couple is applied. Intensity of couple is 25. This distance is 1 and this is 1 and this is our C point. This is B point and this is A. So this 50 pushes upward. So plus 50 into perpendicular distance is 2 and this pushes downward. So minus 25, which is equal to 5 kilonewton meter. Okay. After that we will calculate bending moment at B. Next, bending moment at B, which is equal to bending moment at B. But you observe here at B, before and after couple, 2 points are there. So first we will calculate with couple. With couple. So figure is likewise. Here 15 kilonewton load is applied. Here 25 and this distance is 1 meter. This is A distance. So this pushes upward. So plus 15 into 1. And this and pushes downward. So minus 25, which is equal to how much? Minus 10 kilonewton meter. And now we will calculate without couple. Bending moment at bending moment at B without couple. Bending moment at B without couple. Bending moment at B without couple, which is equal. So here 15. Okay, this is only B point and this is 1 meter. So plus 15 into 1, which is equal to 15 kilonewton meter. And last point is remaining bending moment at A, which is equal to which is equal to 0, because of force is there, but perpendicular distance is 0. So bending moment at A, which is equal to 0. Now we will draw shear force and bending moment diagram. वो रहेंगे राइट साइड ला है ना. मला कोणी सांगेल का होते आपला आन्सर चुकलंय का बरोबर आहे. 16.25 आले आणि एका ठिकाणी 20 व्हॅल्यू आले. येस, ते मायनस असल्यामुळं बघा इथं जरी व्हॅल्यू तुमची मायनस दिसत असली, इथं 20 दिसत असेल तर -20 आहे आणि मॅक्सिमम बेंडिंग मोमेंट किती आहे? +16. मग प्लस मोठा असतं का मायनस मोठा असतं? मग मी चुकलंय म्हणल्यावर तुम्ही शांत कसे बसताय? त्यावेळी तुमचं लक्ष असलं पाहिजे ना की ते मायनस मध्ये हे प्लस मध्ये. आकडा जर डिजिट जरी 20 असतील तर साइन काय आहे त्याचं? मायनस आहे. -20 इज ऑलवेज लेस दॅन +16.25. So our answer is correct. There is no any mistake. Please remember, I am checking your concentration. शिंदे कॉन्सन्ट्रेशन कुठे आहे तुमचं? शिंदे म्हणत असतील प्लस येऊ द्या नाहीतर मायनस येऊ द्या मॅडम. Okay, we'll draw figure fast. So I have to cover one theoretical point today. So this is a point. So guide me fast. Here couple is applied 25 na kilonewton meter, 1 meter span. This point is B. At C there is no any force. Okay, from this C to F uniformly distributed load is continue. At D point 1 point load is applied and intensity is 50, right? 50 kilonewton. The intensity of uniformly distributed load is 10 kilonewton per meter. This is E point. This is D point. This is C point, 1 meter distance. Here 0.5 meter. And this distance is 2 meter. This is F point. First we will draw shear force diagram. Shear force at A, sorry, reaction at A, 15. Okay, RA here, RA which is equal to 15 and RE which is equal to 85 na? 85. Okay, now we will draw bending moment diagram. So bending moment values plus and minus both values are there. Yes, yes, shear force values. Both values are there, na? So first we will draw baseline. Shear force at A, how much? 15 kilonewton. After that, shear force at B, 15, because of there is no any force in between A to B. Up to C, shear force is constant. So we will draw up to C. After that, shear force at D. Shear force at D is minus 10 kilonewton. That means now diagram is going below baseline. So here minus 10. After that, shear force at E, which is equal to shear force at E, which is equal to how much? But at D point, two values are there. Before point load, value is minus 10, and after point load, value is minus 60. So it will go again below. Okay. After that, shear force at E before RE, how much? Minus 65. Okay, so inclined line will be there up to this. After that, shear force at E after this 85. That is shear force at E after RE plus 20. So diagram will be go below, sorry, above baseline. So from here. After that, shear force at F, 0. Okay, so this is the shear force diagram. Now we will, so this is plus, this is minus, and this is again plus. Here 15, here also 15, here also 15. At this point minus 10. Okay, don't write minus, huh? Because of already we have drawn below baseline. So 10, here 60, here 65, here 20, and here 0. So this is A, B, C, T, at D there are 2 points. E, also at E there are 2 points. And F, 0. So this is the shear force diagram. Now we will draw bending moment diagram. So bending moment diagram, plus minus values are there. So above and below baseline we have to draw. First we will mark baseline, and according to this we will draw. So you start from this F point, bending moment at F, which is equal to 0. After that, bending moment at E. Bending moment at E is minus 20. So below baseline, okay, minus 20. After that, bending moment at D, plus 11.25. That means at D above baseline here, suppose 11.25. After that, bending moment at C. Okay, we will mark later because of we have to extend this line. Bending moment at C is plus 5 kilonewton. Okay, so we will mark this 11.5 above. Suppose 11.5 is here. 11 point, how much? 5 or 25? 20. 11.25. After that, bending moment at C is 5 kilonewton. Okay, 5 plus 5, suppose here. After that, bending moment at B with couple and without couple. So with couple is minus 10 and without couple is plus 15. So above this. And now we will mark maximum bending moment point. So I will extend this line first, this 0 shear force line. So maximum bending moment is 16.25. So above this here. This is 16.25. 16.25. This is 10. This is 5. And this point is 15 plus 15. Now we will connect. Up to this C point, diagram is linear, and after that it will be parabolic. Okay, after that whole diagram is parabolic. This is negative, this is positive, this is negative, this is positive. This is A point. This one is last. So this is the bending moment diagram. Okay, I am requesting all of you, please take screenshots. So we will cover last theoretical point. Please take screenshots and let me know after you are taking screenshots. So I will show next slide. Or okay, please write down next point. Point of contraflexion. Point of contraflexion. Point of contraflexion. Okay, first I will draw figure simultaneously. You can also draw here. Suppose this is overhanging beam. And for this we will draw shear force and bending moment diagram. Here support is provided and here also support is provided, and uniformly distributed load is applied on this beam. So this is shear force diagram, and for this bending moment diagram will be likewise. Okay. So from this, these are the point of contraflexures. These are the point of contraflexure. So please see here, point of contraflexure means at this point bending moment is 0 and the bending moment changes sign from negative to positive or positive to negative, or in other words, the point at which bending moment changes from sagging to hugging or vice versa, and at this particular point the value of bending moment is 0. So this point is called as point of contraflexure. सिम्पली काय लक्षात ठेवायचे की ज्या पॉइंटला बेंडिंग मोमेंट 0 असते आणि त्या पॉइंटला जर बेंडिंग मोमेंटचं साइन चेंज होत असेल तर त्या पॉइंटला आपण काय म्हणणार आहे, पॉइंट ऑफ कॉन्ट्राफ्लेक्चर, पॉइंट ऑफ कॉन्ट्रा शियर. ज्या पॉइंटला शियर फोर्सचं साइन चेंज होतं पॉझिटिव्ह टू निगेटिव्ह, दिस पॉइंट इज कॉल्ड ॲज पॉइंट ऑफ कॉन्ट्रा शियर. आणि बेंडिंग मुवमेंट मध्ये जर चेंज होत असेल तर त्याला आपण म्हणतो पॉइंट ऑफ कॉन्ट्रा फ्लेक्चर. ह्याच्यावर एक एमसीक्यू डेफिनेटली विचारणार, एक एमसीक्यू असणार ह्याच्यावर. पॉइंट ऍट विच बेंडिंग मुवमेंट इज झिरो, दिस पॉइंट इज कॉल्ड ॲज पॉइंट ऑफ कॉन्ट्रा शियर पहिला ऑप्शन असणार बरं का. पॉइंट ऑफ कॉन्ट्रा फ्लेक्चर दुसरा असणार. मग त्याच्यातून आपल्याला पहिले काय वाटतं लगेच पॉइंट ऑफ कॉन्ट्रा शियर आहे. पण फ्लेक्चर म्हणजे बेंडिंग, फ्लेक्चर म्हटलं की बेंडिंग मुवमेंट मध्ये येणार आहे आणि शियर म्हटलं की शियर फोर्स मध्ये येणार आहे. ठीक आहे, प्लीज राईट डाऊन डेफिनेशन. द पॉइंट, राईट डाऊन डेफिनेशन. द पॉइंट in a beam, the point in a beam, in a beam, the point in a beam, in a beam where bending moment goes, where bending moment goes from hogging to sagging, or vice versa, hogging to sagging or vice versa. The meaning of vice versa is hogging to sagging or sagging to hogging. Okay, vice versa. स्वल्पविराम. Bending moment becomes zero, bending moment becomes zero, bending moment becomes zero. That point is called as point of contraflexure. Point of contraflexure. Okay. And from this one sentence, please remember, point of contraflexure most of times comes in overhanging beam. ह्याच्यावर MCQ असतो. Point of contraflexure most of times comes in overhanging beam. Okay, so this is the point of contraflexure. Then we will move towards our last point, that is in relation between, most important point. Up till now we have solved numericals, but what is the relation between loading, shear force and bending moment? This is the most important point. So please write down relation between intensity of load, shear force, load नंतर स्वल्पविराम, intensity of load स्वल्पविराम, shear force and bending moment. Okay. Now I will derive here one equation. You concentrate here. Okay, so first I will take one beam. Suppose this is a beam, and the shear force and bending moment calculation does not depend on type of support, but shear force and bending moment calculation matters in type of loading. So we will assume here any type of support, not matter here. Okay, so this is, we have taken one beam, and from that I will take one section or one wedge here, small section, at a x meter distance from A. Suppose this is AB beam, and in that I have taken one small section at x meter distance from A point. Okay, and on that beam here uniformly distributed load is applied. Okay, and the width of this section we will call as a dx. We will call as a dx. Now I will draw this figure separately. That means I will exaggerate. Means I will zoom this figure or zoom this section. After that, this section will see likewise. This section will see likewise. And here uniformly distributed load is applied. Here this is dx. Okay. Now we have taken section here. No, that much more, not more derivation here, less derivation. One or two steps there. Please concentrate here. So here uniformly load is applied W kilonewton per meter. Okay. So when we will cut this, at that time here shear force and bending moment will come. ज्यावेळी आपण बघा एखादा बीम आहे त्या बीम वर जर आपण लोड अप्लाय केला तर त्याच्यामुळे डेफिनेटली शियर फोर्स आणि बेंडिंग मोमेंट जनरेट होणार आहे. त्या फोर्स मुळे आता समजा हा बीम आहे सिम्पली सपोर्टेड बीम. सो आफ्टर ऍप्लिकेशन ऑफ लोडिंग here shear force will be generated 5 kilonewton, here generated 5 kilonewton, and due to this load beam will bend likewise. So whenever we will apply load on a beam, at that time shear force and bending moment will generate. So here also shear force and bending moment will be generated. So suppose we will assume shear force here yes, and in this direction opposite shear force yes plus ds. Okay, yes plus ds because of due to this section, and one movement will be there. Suppose here m movement, so at the same time here opposite movement will be there, m plus dm, m plus dm. So here we have to take partial derivative. Okay, up to this anybody having doubt? Okay, now this is our figure. Here we have to apply equilibrium equation. Okay, here we have to apply equilibrium equation. So apply equilibrium equation. Equilibrium equation. So how many equilibrium equations are with you? Summation of Fv and summation of movement. Two equations we are using, but there are total 3 equations. Summation f h which is equal to 0, summation fv which is equal to 0, and summation movement at any point which is equal to 0. Okay, this fh we will consider when horizontal force is there. So here horizontal force is not there, so we are considering only these 2 equations. So equilibrium equations we will apply here 2. So out of that, first is summation fv which is equal to 0. And for this already you know that vertical forces we will consider positive, and sorry, upward forces we will consider positive, and downward forces we will consider negative. So according to this, here how many vertical forces are there? This yes plus ds, and this w. Okay, so we will write here. So this here going upward, so plus this s plus ds going downward, so minus s plus ds. After that this w again going to downward, so minus w into span for this is dx which is equal to 0. Now we will multiply by this minus 2 bracket, so s minus ds, because of minus plus is minus. Then we will shift this plus w into dx to right side. So w into dx. Okay. Or we will write as it is. Okay. So minus w into dx which is equal to 0. This plus s and minus s gets cancelled. We will shift this minus ds to right side. Minus w into dx which is equal to ds. Okay. So finally, ds divided by dx, which is equal to minus w. So this indicates first derivative of shear force, you will get the value of load. जर तुम्ही shear force चा first derivative घेतला तर तुम्हाला load मिळतो. This is the relation between intensity of loading and shear force. Now we will see what is the relation between shear force and bending moment. Okay, so for this we have to apply second equilibrium condition. And what is our second equilibrium condition? Moment. We will apply here. Okay, so our second condition is summation moment at any point which is equal to 0. We will take moment here. We will take moment at this point. Okay, so this m clockwise. Okay, so m. After that, this m plus dm is anti-clockwise. So minus m plus dm. Okay. After that, this s again clockwise. So plus s into distance is dx. And this s plus d is acting here. Acting this point, so will not consider. Okay. Now this w is remaining. So this creates anti-clockwise. So minus w into dx. This is load. And after that, it will act at dx by 2, which is equal to 0. So this is very small force. Okay. This is very small force. So we will neglect this. We will neglect this. Now what is remaining? M. We will multiply by this minus. So minus m minus dm plus s into dx, which is equal to 0. This plus m and minus m gets cancelled. Okay. Now we will shift this dm to right side. So s into dx, which is equal to dm, which is equal to dm. So s, which is equal to dm divided by dx. That means it indicates first derivative of moment, you will get the value of shear force. So which is equal to s. म्हणजे ज्यावेळी तुम्ही मोमेंटचा फर्स्ट डेरिव्हेटिव्ह फाइंड आउट करणार त्यावेळी कशाची व्हॅल्यू मिळणार आहे तुम्हाला? शियर फोर्सची. आणि ज्यावेळी तुम्ही शियर फोर्सचा फर्स्ट डेरिव्हेटिव्ह घेणार त्यावेळी तुम्हाला व्हॅल्यू कशाची मिळते? लोडची. तर त्याच्यासाठी आता एक एक्झाम्पल तुम्हाला इथे मी सॉल्व्ह करून दाखवते. कुठली स्टेप सांगू द्या सांग. हे so here we are going to find out moment at this point. Okay, so this s creates clockwise movement towards this point. That's why plus s into dx. Okay, this m already clockwise. That's why we have written here plus. This m plus dm anti-clockwise. That's why minus m plus dm. Then this w creates anti-clockwise movement toward this point. So minus w into dx, that is force into span, and it will act at dx by 2. But the amount of this force is very less, so we will neglect. Okay, and I have not considered this s plus ds because of this force is acting on this point. So here perpendicular distance is 0. That's why I have ignored this. Now we will multiply by this minus 2 whole bracket. So minus m plus m gets cancelled. This minus plus is minus dm and s into dx is remaining. After that, I have shifted this minus dm to right side. So s, which is equal to dm divided by dx. So dm divided by dx, that means when you take derivative of this movement, at that time you will get the value of shear force. And if you take the derivative of shear force, at that time you will get the value of load. So this is the relation between intensity of loading, shear force and bending moment. Okay, suppose you observe in overhanging beam, in uniformly distributed load. In uniformly distributed load, moment equation is in terms of x raised to 2. Please recall. बघा बेंडिंग मोमेंट मध्ये काय होतं की युव्हीएल ची x ची पॉवर 3 होती, त्याची बेंडिंग मोमेंट डायग्राम क्यूबिक पॉलिनोमियल होती. बरोबर आहे. सो वी विल राइट हियर k into x cube. This is suppose movement term. Okay, this is momentum. Now I will take derivative of this k into x cube. So what is the derivative of this k into x cube? 3k x square. So it means the value of shear force for this uniformly varying load is x raised to 2. X raised to 2. So this is the shear force. Now I will take the derivative of this 3k x square. So derivative of this 3k x square is 6k into x. This is the load. So when you will take first derivative of moment, you will get shear force. And if you take derivative of shear force, at that time you will get load. So this is the relation between intensity of load, shear force and moment. Got it? Okay, please write down. Or if you want, take screenshot. Without writing, please take screenshot. Yes, so we will stop. Last one problem is remaining. Yes, yes, we will continue tomorrow. हे प्रॉब्लेम साठी नाही, दिस इज ओनली थेरॉटिकल कन्सेप्ट. प्रॉब्लेम मध्ये असं तुम्हाला निग्लेक्ट करायला व्हॅल्यू येणारच नाही, तिथे काहीतरी व्हॅल्यू दिलेला असणार आहेत ना. So today we will stop here. Thank you for attending lecture. Thank you. तो फिर तुम भी आओ ना ऑफलाइन. कौन आपको जे कोणी असतील ते पण येऊ द्या ना ऑफलाइन, काही प्रॉब्लेम नाही.